Yeah, I'm Zili Ren. I'm a PhD student starting in the University of Sheffield. Yeah.
Yeah, I'm Duncan Herford, Chief Scientist for Chementir, and I'm one of the industrial mentors for the project.
And I'm John Provis. I'm here representing the University of Sheffield in my role as visiting professor there.
Yeah, my project is mainly make some clinker, and the clinker will be made under different cooling regimes to study the effect of cooling rate. And at the same time, we also will mainly study the effect of magnesium in the clinker and with other mining elements, for example, sodium, zinc, sulfate, something like that. We hope to get a high quality clinker with lower energy requirements. That's our project.
Well, I think the impact is that firstly it allows us to use hopefully raw materials that so far have been excluded, ones that are high in magnesium, for example, and it allows us to optimize our process, cooling rates and things like that in the kiln to accommodate for that. And ultimately what we want to do is to maximize the performance of the clinker, because any extent that we can lower the clinker content in cement to give us the same performance in concrete, a major part of that is that we're able to maximise the performance quality of the clinker. So we can lower CO2 emissions in the cement for the same performance, but at the same time, some of the other pillars like carbon capture mean that we can lower the capital investment and operational costs of that if we can lower the amount of clinker we need to produce to put cement on the market for the concrete that we still need to produce.
For my project, I'm going to study the effect of more minor elements in the clinker. Yeah, and hopefully we can do some data for the database for the people who want to calculate the clinker phases, clinker energy. That would be helpful for the maybe company factory to save their energy and reduce the CO2 emission. Thank you.
Yeah, and I think as a part of that, we will also focus, I think, more towards the end of the project on performance as well, with the hydration tests we're doing at Aachen University. And we have other ideas for future projects as well that hopefully this can feed into.
And the other aspect in terms of developing future research and future value out of this is that cement clinkerization in the academic world it's almost an untouched topic. It's so difficult to build the infrastructure, the skills and the facilities to be able to do this, and the partnerships it takes to make sure we're doing it correctly, that now that's in place, we've got a platform and a basis to continue working, continue collaborating, and yeah, there are many, many more questions to ask. So in terms of designing a collaboration to solve a real problem, this setup we have here through the Innovandi Core Project is an absolute dream, because we've got the industrial input, the people who know what the real questions are, and work day to day on site at full scale in clinker production. And we have that expertise across multiple cement companies, multiple different industrial partners. We have an academic collaboration between specialists in different aspects of the process, different aspects of the science, and bringing that together to really focus on the core underlying questions. So it's good science, it's cool science, and that's really important in a PhD project, that the science is really new. But by engaging so closely across the different partners and between the industrial and academic side, we can also be absolutely certain that it's not only cool, but it's really relevant. And as a researcher, that's really motivating. You get the opportunity to do something that's going to make a difference and to train an excellent up-and-coming new researcher in both the science, but also how to use the science. And to me, that's really exciting.